Linting is the process of checking source code for programmatic as well as stylistic errors. Ruff is a highly popular Python linter written in Rust. It was developed by Charlie Marsh, who also founded Astral, which is focused on next-generation Python tooling. Charlie joins the podcast to talk about open source development, Ruff, the UV package installer, and much more. This episode is hosted by Josh Goldberg, an independent full-time open source developer. Josh works on projects in the TypeScript ecosystem, most notably TypeScript ESLint, the tooling that enables ESLint and Prettier to run on TypeScript code. Josh is also the author of the O'Reilly Learning TypeScript book, a Microsoft MVP for developer technologies, and a live code streamer on Twitch. Find Josh on Blue Sky, Mastodon, Twitter, Twitch, YouTube, and .com as Joshua K. Goldberg.
Charlie, welcome to SED. How are you?
Thank you so much for having me. I'm doing great. Really excited to be here.
Well, that's great. We're happy to have you. You've been working in programming and open source for a little while now across multiple languages like Python and Rust. Could you tell us how you got your start in programming?
Yeah, sure. Let's see. I taught myself programming Java the summer before I went to college. I had some time to kill, and people had always told me that I would really like it. And so I spent some time kind of learning how to program in Java before I went to school. And then by the end of that summer, I was pretty convinced that I wanted to do computer science as a major. So I spent 4 years at school doing computer science. And, in that time, I started to have some interactions with open source. So I guess my first real brush with open source was a friend and I worked on this project. We created this thing called Jasper, which was kind of like an open source Alexa before Alexa existed. So it was ahead of its time, but it was also not very good. Like the speech to text was not good, but it was scriptable and people could kind of write their own modules. And that was open source, and it kind of blew up a little bit. Like it was on the front page of Hacker News, and there was a Wired article about it and a Forbes article about it. So it was kind of a cool thing where we built this thing for ourselves because we thought it was cool, and then just saw it kind of explode and saw this ecosystem grow up around it of contributors and lots of people using it and all that kind of stuff. So that was my first brush with open source. And then, since I got started in industry, after graduating, I would say I've really been more of a consumer of open source than a maintainer. And, my experience, over the past year and a half since we launched Ruff and then UV, the two tools that we've been working on in the sort of Rust Python ecosystem, I've kind of had a crash course in what it's like to be a maintainer because I came into that experience again, mostly as a consumer of open source, right? I've worked in the web ecosystem and made some contributions there, but I've never been a maintainer of anything big. So that's been a very interesting evolution for me over the course of the past year, which was, you go through this kind of phase of you start the project and no one really cares about what you're doing, but you have a few enthusiastic people and you're kind of doing whatever you can to make them happy and make sure that you're building for them. And then, over a period of time, we evolved to now we have a lot of users and everything we ship, gets feedback and gets tested within 5 minutes. So it's been kind of an interesting evolution for me as a programmer, going from someone who mostly consumed open source to now someone who spends most of their time maintaining open source over the past year and a half.
Do you prefer the earlier stage versus the later stage as a person who has to work on the project?
Yeah. I think it is almost strictly more fun. I have this, it's different, right? The position that we're in right now, with Ruff, for example, we have well over 10 million downloads a month. Tons of the biggest projects in Python are using Ruff. We have I don't know, our VS Code extension has 500,000 downloads or something. So we have a lot of users. And with that comes, it's with great power comes great responsibility. Right? It's we have, there's a ton of impact to everything we do, which is awesome. But we also have to be way more careful about changes that we make. So when I started working on Ruff, it was really the Wild West. I was shipping releases sometimes more than once a day. I wouldn't say I was intentionally breaking anything, but things were breaking, right? I was changing the interface a lot, and I was just kind of doing whatever, because I was moving really quickly and there weren't that many users. And like over a period of time, that became, even if we weren't shipping breaking changes, like shipping twice a week became way too much. And people were like, this is changing too often. Like my CI is updating every day. So, over time, we kind of pared that back. And so everything we do now, it's like when we ship something, we know we're shipping it to like a really large group of users, and that it's kind of a cool feeling to be like, okay, if we add a new rule with an auto fix, like suddenly that's going to show up as an editor integration for like this, huge group of users. Like everything we ship, it's a really good platform for impact. But I do have this weird like feeling that, of course, I believe this because it's the way that I feel about this project. But like the hardest part, I think, of building software really is like compatibility. Like I think if you never had to think about users and never had to think about like maintaining compatibility or anything like that, like building software would be like so much easier. It's the exact reason why like hacking on prototypes and stuff is like way easier than like working in an established project. Because now with Ruff, every time we want to make a change, like we just have to be really thoughtful about how that gets communicated, how it gets rolled out. We have to maintain the existing version and the new version for some period of time. So I find it a lot more fun to work in the early stages of the project, but the later stages are very rewarding. And getting constant feedback from users is something you often don't have in the early stages of a project. And it's part of what makes open source, I think, really fun.
Absolutely.
Like you have this direct relationship with users that just doesn't really exist in the same way in a lot of other categories of software.
Yeah. Before we dive into kind of what is Ruff, why would you write a Python linter in Rust, I want to explain agreement with that point that there's always this push and pull of the more users you have, the more restricted you are in dealing with them. For example, you mentioned breaking changes. No one likes breaking changes twice a week. But if you don't have users, it's hard to, get ideation for your project, get feedback from people. So it would be lovely if we could find an area of the industry that had kind of the ideal setup where we have a lot of users, but we're still able to do things quickly. And I think building for developers is as close as I've ever seen to that, where developers are the most comfortable understanding the concept of, say, a breaking change. Have you found that to be the case as someone who also works in the linting space?
Yeah, I think well, first of all, I love building for developers because, you can like cheat a lot because you're kind of the ideal user. Or not ideal, but you are an example user. So you get to rely on your intuition a lot. And you're working really closely with people who have very similar problems and experiences to you, which I think can be really energizing. The main thing that I've found with like breaking changes and the like is the most important thing for us has been to have clear expectations around them. Like we didn't have a versioning policy for a long time. And so people were like, we don't know what to expect when we upgrade Ruff. And like, as long as we know what to expect, we can like act accordingly. But if arbitrary patch releases can contain arbitrary changes, like it's just very hard for us to know, should we upgrade Ruff or should we not? And so like one of the best things we did was we added a very formal versioning policy where we wrote out all the rules for, it's not exactly Semver, it's like close to Semver. I don't know. Anyway, we have a versioning policy. It's a little complicated, right? Because like, is adding a lint rule a breaking change? Like we had to kind of grapple with some of those questions. But we have a versioning policy around when we bump patch releases, when we bump minor releases. We have a whole like preview mode where, you can kind of opt into changes that aren't yet stabilized and all that kind of stuff. So we've had to put a lot of effort actually into making that work. I think it works really effectively. And now that we have clear communications around it and expectations around it, people have been a lot more understanding.
That's great. Let's talk about that understanding concept. Can you just from the very start tell us why is it that you would write a linter for one language, Python, in a completely different language, Rust?
Yeah, totally. So a lot of what I started doing with Ruff and now with UV, like some of the inspiration for that came from things I saw in the web ecosystem, where in web in particular, there were all these sort of CPU intensive problems that web tooling was naturally buying into or accepting, like the fact that you had to bundle your code and minify your code. Like those are concepts that don't really exist in Python, for example, but they did exist in JavaScript, right? So everyone needed to bundle their code and bundling became slow. And that at some point led to the birth of ESBuild. And, it's not important whether it's like Rust or Go or whatever else, but the idea was, we can empower people who are building in JavaScript by writing like the foundational tooling in other languages that might enable us to write more performant foundational tooling. And it should be done in a way that is completely unintrusive to the user. Like to use ESBuild, you don't need to know anything about Go, or you don't need to be able to write Go. To contribute to ESBuild, you do, but to use it as a user, like it should be kind of just transparently useful to you. And like Ruff is based on very similar ideas, which are, we think that Python tooling could be really different, and I would hope in a way that is better, by leveraging, in this case, Rust, for example, to help us write tooling that scales to much larger and more complex projects. And a lot of that's based on my own experiences, whereby, I was maintaining a pretty large Python code base. Well, I mean, large by my standards, not by like Google standards or anything. But, we were a team of like 10 engineers, and, we had a lot of tooling. And I was just sort of sitting around thinking, like, it feels unusual to me that my linter takes like 1 to 2 minutes to analyze our code base, because we're a team of less than 10 people. We have like a moderately sized project. And this isn't a feeling that I really experience in some other ecosystems. So like, is there a fundamental reason why my linting has to take that long, for example, was kind of the motivating question. And, the thing that I was seeing was like in web, there was more tooling being written in non-JavaScript. And then in Python, there are really, really good tie-ins actually between Python and Rust. There's a very good ecosystem of tooling that enables Rust Python bridging in different ways. So Rust was kind of a natural fit for that. And the real motivation there to start was like, let's try to build something that's much, much faster with few or no caveats or sort of like hindrances for the user. So it should just be a tool that feels the same in terms of, let's try to make something that doesn't have any trade-offs, I guess is the way I would put it, but is much more performant. And that was kind of like the motivating thinking behind Ruff. It was like, I think there could be much faster Python tooling. Let's see if Rust can enable that. And then let's see what kind of trade-offs we would have to make in order to make that possible.
That's fascinating that you're actually able to optimize for no trade-offs. That's not something you normally hear in software engineering and design.
There definitely aren't no trade-offs, but I think the trade-offs are good. Like the trade-offs or the negative trade-offs, which are worth talking about, of like building Python tooling in Rust, for example. Like some of them are, one, we're shipping like big binaries, like our tools are like big compiled binaries. And so that's really different than shipping, a bunch of Python files. So there's like a binary size element to it. Like our development process is more complex because we are writing Rust, and then we have to kind of like build native artifacts and publish those. So like our development and release process is more complex. The third is we don't really have access to like the Python standard library or anything like that. So like often, in Python linters that are written in Python, they might need something from the standard library, like a parser. Hey, parse this source code, right? Or, hey, given a string, is this like a valid variable name, right? Like that's like a reasonable thing to ask. And there are things in the standard library that enable all of that. The standard library has a parser and it has, things like that you can leverage. Like we don't have access to any of that. So like if we want a parser, we have to write our own parser, right? And maintain our own parser. And we do. And like as new versions of the language come out, like we have to keep up with that and implement all of that. So that's like, there's a big maintenance cost to that, which is we have to keep up with Python itself because we can't leverage the standard library or anything that's built into it. And then the biggest, the limitation or the drawback that I hear about most often, which I think actually hasn't been true for us, but I think can be true in general, is this idea that like, if you build Python tooling in Rust, for example, or JavaScript tooling in Rust or JavaScript tooling in Go or whatever, you will not be able to create like a community of contributors because there will be a bar to contributing and getting involved, because most of your users write Python for the most part, probably, and they may not know Rust. So that's like, that statement is probably true. But for us, at least, we haven't really had like problems at all with creating, like bringing in contributors and creating a strong and sustainable contributor base. You've actually had a lot of contributors who it's their first time writing Rust, and they see Ruff as an interesting entry point for them. They want to learn Rust, they know Python, they're looking for some place to contribute, and they see Ruff actually as like a place for them to go and contribute and kind of learn Rust. So I don't know how it would work if like every tool in Python was written in Rust. Would there be enough people, right, to contribute and maintain those tools? Like that's kind of a different question. But, for us at least, we have like I should have looked before coming on the show. I don't know. We have like a couple hundred contributors, right? We have like a lot of contributors and we get tons of issues and PRs and a lot of people who want to come in and learn Rust and see this as a way to do so. So, I think it can vary a lot. It's definitely a higher bar to contributing than a tool that's written in the language that it's meant to serve. 100%. Like that's just indisputably true. But I don't think it's necessarily true that it's impossible for people to contribute or that you won't be able to find contributors.
Your contributors graph on GitHub has exactly 100 contributors from August 7th, 2022 to March 14th, 2024. And you have more commits roughly than everyone else combined. Nicely done there.
I thought we have 396 on the front page contributors.
Huh. Well,
I don't know what the difference is.
Tooling is hard. But It's a bit of a chicken and an egg problem, no? That if you have an ecosystem largely driven by contributors in one language, it's hard for them to move to a different language, which means you have fewer people in that other language, and then the cycle continues. So if anything, having good, important, new, experimental to stable tools like Ruff exist is a good forcing function to make it so that more people jump onto this new type of tool, which can then make more of this type of tool happen, no?
Yeah, and I think, again, I'm not trying to necessarily say that there's no cost to, writing the tool in Rust. Like there are definitely a lot of people who would like to fix an issue, but they don't know Rust and they don't have time to learn it, or they don't have motivation to learn it, or something very reasonable. And like that definitely does happen. I think for us, the best thing we can do is like try to make it an inviting project for people who do want to learn Rust, right? And do want to use this as either an excuse to learn some Rust or like an opportunity or an entry point or something like that. So, trying to have good like contributor documentation, being willing and able to like mentor people who come in and write Rust, right, for the first time and give them feedback and kind of coaching them through it. Like those are all things that we try to do. And you're right. Like I think it can compound over time. Like we've had contributors in Ruff, which we released like August 23. So I think, August 22. And now I'm getting confused, like a year and a half ago. We've had contributors there who then contributed to UV, which we released like, less than a month ago. And those people, like, I don't know how much Rust they wrote before they contributed to Ruff. It totally depends, person to person, but like, there's definitely people who like, we see them again on our different projects. And so it's cool to see that growing a little bit. It's still very nascent in Python, I think, but it is becoming more popular.
I want to talk a little bit about the difference between what a linter means in, say, Python versus Rust versus other languages. Every language has a different concept of what is a formatter versus a linter versus a type checker.
Right.
And Python in particular, I think, has a really interesting what is a type checker model, given that it's a very dynamic, intentionally fun and loose language that has had types added to it over time. So from your perspective or the Ruff perspective, what is the role of a linter in a language like Python?
Yeah. So, I guess, one thing that's happened with Ruff, so prior to Ruff, I would say the Python ecosystem, the static analysis tooling was this word sounds pejorative. It's not necessarily meant to be, but it was very fragmented, right? Like there were a lot of different tools that were intended to be used together. And so like, for example, like import sorting and making sure that your imports are sorted and organized, that was a separate tool called isort that was viewed as distinct from a linter. And there were lots of different linters that covered more narrow categories, and some of them had plugins, but there were also standalone tools like PyUpgrade, for example, is a very common tool. It's a linter that includes code mods, but it effectively exists to try and upgrade you to newer syntax or newer standard things in the standard library. So if you're going from Python 3.8 to 3.10, there's a bunch of stuff you can fix or change or upgrade, and it exists to serve that role. And so one thing that happened in Ruff, like sort of by accident, is we ended up consolidating a lot of tooling into one. And I sort of say like performance for Ruff was like the flagship feature, but I think one of the most impactful things for users has actually been that like Ruff now bundles a lot of different stuff together. And so when people migrate to Ruff, they're often replacing like 20 or 30 tools with one. And so in Ruff, like import sorting is a lint rule, right? It's just another rule amongst many others. I would say, and I guess the other thing that's different about Ruff is like we do a lot of code modification. So we do a lot of like, I don't know about most, not quantitatively, but a lot of our rules ship with auto fixes. And so we'll do, code transformations to try and fix them automatically. So like for Ruff, I would say the linter is really about like trying to identify potential problems in your code that are not type errors. We view that as separate. So it's not about type checking, but trying to identify potential problems in the way that you express an idea and trying to hint people towards better ways to do it, or oversights or other kinds of mistakes. But it's very distinct from a type checker. Like we don't do any type checking in Ruff. We sometimes like leverage type inference to be like, oh, this is probably an integer. And so it's unsafe to call this method with an integer. We might do things like that, but it's a little bit different. Like that's actually a good example. Imagine it's unsafe to like call some method with like an argument of a certain value. Like maybe you're doing some like cryptography thing and the argument it takes is like an integer that indicates which hash algorithm to use. Like a type checker would be fine with like any integer, probably. But a linter could actually say, yeah, this value is considered like unsafe or unsound, or this isn't that cryptographically secure. So a linter, it's not necessarily about validating that the types of things are correct. It's more about understanding the behaviors and a lot of the library specific and domain specific concepts and the ways they might be misused.
Do you have the ability to have library or specific lint rules loaded in by users for their specific library or framework?
No, we don't support any sort of like user provided or user defined rules or plugins right now. And that's actually like part of why we ended up bundling so much stuff is in the early days of Ruff, I couldn't really see, and I have more ideas around this, but there wasn't like a clear and obvious path to like user plugins and like user provided rules, because like in Python and in JavaScript, that's much more straightforward because the languages are so dynamic. So like people can just kind of like hook into what you're doing and you just like run some JavaScript or run some Python to run their rules. Like in Rust, that's a lot more complicated because everything's compiled in ahead of time. And so the idea of like a user providing a rule and being able to run that like an arbitrary rule at runtime is just, there are interesting ways to enable that, but there aren't like clear and obvious and established ones. And so at the time it was like, okay, people need this set of lint rules in order to adopt Ruff. Okay, I'm actually just going to build those into Ruff. And that is what became like the current system. It was like, okay, people need these like docstring related rules. All right, let's add support for linting docstrings. And it kind of like spiraled out from there.
If anything, that might be a strong value prop for you. In ESLint, the JavaScript linter, we have all sorts of user pains from these multi-hundred line ESLint configs. There's a new what's called flat config system that's being migrated to as we speak. It's a lot of user pain. And there is value in these user plugins, but the fact that you've built so many things such as docstring validation internally to Ruff, I imagine must mean a very nice, smooth user experience for trying to adopt Ruff from a new project.
Yeah, I think it's ended up being a strength. So first of all, like I think it's a better experience for users. I think second right now, and I think second of all, it's been really helpful for us as maintainers to effectively not have a public API, which I know is like a little bit of a callous thing to say. We do have a public API, but the public API is our command line. And so like we don't have users who are like using Ruff as a library. And that just gives us a ton of flexibility because we can effectively change like anything we want right internally and do a lot of refactoring. And, the tool is just very much in flux as we're just developing it, pretty aggressively. So it's been actually really helpful to have those boundaries. And I think there is a little bit of a difference. Like people still want custom rules, and I think it's still interesting to think about how to do that. And I'm quite interested in supporting it. I do feel like there's a little bit of a difference between like plugins and custom rules, which maybe sounds strange, but the thing that I see that people want the most is like rules that are specific to their application. Like a plugin would be like a way to lint doc strings, but a custom rule could be like when you're in this class, like you can't import things from this other module. Like a custom rule, in my mind, the things that I see that people still want, even though we bundle a lot of stuff, is like ways to enforce things that are specific to their application or in some ways proprietary or like domain specific. Like that's kind of what I'm more interested in enabling because that is something that every company has.
Sure. Let's talk about companies a little bit. A lot of companies, a lot of dev teams, web platform, dev platform teams use linters and other nice static analysis tools to help make sure that the developers are writing, safe, consistent code, whether it's logically consistent, stylistically, and so on. If you were to try to sell Ruff or to advocate for Ruff to a dev enablement team, what are the points you would make around features that we haven't yet talked about or would pull it all together?
Yeah, so I think, like I said, the flagship feature is like performance. The second is simplicity, but there are like a few others that have been really important, I think, to Ruff's success. One is like, we just had a really strong focus on making it easy to adopt. And so like from the start, we basically mapped our rules back to existing other linters so that when people migrate, they should see effectively the same, sets of violations. And that's been like a really helpful thing because people moving from project to project, they already recognize the rules, they're already familiar with them, their projects are probably already in compliance with them. So like lowering the activation energy, right, required for people to actually use the thing, I think is really important. And, over time, we are going to like ask more of users, right? We're going to like try and change user behavior in meaningful ways. But like, and by that, I mean like, it's not necessarily clear that that's the best possible API for Ruff. It's just the most convenient one for people migrating over. And eventually we might be able to come up with better APIs and maybe better tools to help people get started and all that kind of stuff. But having a really quick on-ramp for people, I think is like, it's underratedly important for adoption and for getting people to buy in on your thing. Like if you have something that's actually drop-in compatible and it has X, Y, and Z benefits, and it's like, 10 or 100 times faster, like suddenly people have to come up with reasons like not to use your thing. Like they have to be like, this is why I'm not using it, right? Like you kind of invert the calculus around like decision making. And so that's, from a developer marketing perspective, that's sometimes how I think about what we build. It's like, how do we make it? We should make it as easy as possible to adopt with clear and obvious and like indisputable benefits. And then we should look at all the reasons that people can't adopt it. And we should just like somewhat ruthlessly like go inspect those and understand, can we fit that use case or can we not?
It's a funny word to use there, ruthless, because in a sense, you're right.
Yeah,
of course,
you're
looking at these problems and aggressively. No, it's a good word to use because it's a negative connotation of ruthlessness, but it's a positive application that your early stages of a tool, you're really building it out. That's what you're doing right now. You're figuring out what are the problems in the ecosystem and trying to solve them in a way that users can stomach.
Yeah. And, that was sort of an attitude that I developed when working on Ruff early on, because there were, there'd be a project that's like, I really want to use this, but it needs to implement like import sorting. And by ruthless, I mean, then I would just be in my head, I would just be like, all right, we're going to add import sorting. Then it would be hard, right? But I would sit down for a few days and just figure it out. And like, just focusing, I think just people, like you just have to like really honestly ask yourself, like what's stopping project X, Y, or Z from like using my thing? If you want your thing to be used, which is a totally separate question. Like a lot of people build things and like, this is not their goal, and that's totally fine. But if you are trying to build something and gain some traction and momentum, I think you just need to really look honestly at other projects and be like, what's stopping them from using my thing? What are the things that are getting in the way? It doesn't mean that you have to do everything the same way as an existing tool. Like that's not necessarily the lesson, but you do have to, think about what trade-offs are you making? Like, what are you asking of the user? And what is it buying? What is it buying you to do that or not?
It's a much smaller activation energy to go from not using your tool to using your tool with the same settings. It's basically just the same thing and faster than alternatives. And then it's also a much smaller activation energy to go from that state to using your tool with more powerful, better APIs as opposed to not at all.
Yeah. And that's kind of that's like part of the transformation that we're thinking about now is like, if we started from scratch and said, what do we want Ruff's API and interface to look like? And we didn't have influence from existing tools, what would we do? And is there a way for us to make it so users who are already using Ruff to migrate to this new system, in a seamless way? So it's a lot of the same principles, which is like, think about how you make things as easy as possible for users. Like a linter, especially, like the linter is not going to be the top priority thing for most teams. It's not going to be the most important thing, right? Like they probably have other things to prioritize, and it could be a huge quality of life improvement for them, but even still, it might be hard for them to prioritize. And so like putting yourself in a position where they actually can prioritize it is one other way to think about it.
Absolutely.
It's the most important thing in my life, right? Working on the linter, but it might not be the most important thing in their lives.
Absolutely. Let's talk a little bit about the long term then. We've talked about onboarding to linters, to Ruff, and so on. The industry is going through a little bit of a slow upheaval with AI and general dev tooling enhancements. And it looks like linters and linting and static analysis are also going through a nice set of revitalizations. What do you see as the next 5 to 10 years of linting in Python, Rust, and similar?
So I think especially the intersections with AI are pretty interesting. Like I've seen, well, for one, so I think that it's interesting to think about the role and importance of static analysis tools as we get towards a world where more and more code is generated non-deterministically. So I think about this sometimes, like if people are generating more code, I think the value of tools that are consistent and explainable and reliable actually kind of potentially goes up. Like if you have a bunch of generated code, the idea of having a linter to enforce consistency and style and correctness, I think is actually more important potentially than it is today. But the other thing to think about with AI is like, there have been some interesting explorations around like LLM powered linters. So linters where maybe you like describe a rule in plain text or you give it a few examples and then it figures out how to detect it on your code base. I think that's pretty interesting. I actually built like a little bit of a prototype around this before I released Ruff. It was called Autobot, and it was kind of meant to be like Copilot for your code base. So you gave it an example, you gave it a before and after, you gave it a diff, and then it would go and try and apply that diff to usages across your code base. And I think that's quite interesting, the idea that you could take things like custom or domain-specific logic, things that you could describe in plain text and figure out how to map those onto lint rules. I think the thing that doesn't really capture is that most people actually don't want to be writing their own lint rules. That's actually a lot of the value of a linter, I think, is you're putting together a curated and opinionated set of rules. And most people don't want to sit down and like develop their own taxonomy of rules, even if it was made very easy to do so. So I think the value of this stuff still remains very high. I think it totally depends on it's just very hard to predict what people's relationship to code will be in 5 or 10 years. That for me is the part that's very hard to predict.
Absolutely.
I'd be curious to hear your opinion on it, actually.
Oh, absolutely. Be happy to. I think that one of the many interesting things about the AI revolution that's happening is that for the first time in a long time, we are seeing the average quality of written code go down. AIs write really, really bad code. It's extremely difficult to understate how bad most code written by AIs is. So the value, as you said, of tools such as linters, of type checkers, static analysis in general, that can look at code and tell you exactly what's wrong with it and how to fix that, especially as Ruff does support fixing, as you noted, that goes up. That's really good. And of course, AIs are going to get better over time. We're just seeing the very, very early onset of them. And a comparison I like to make is that saying that AIs are going to replace developers is like saying that a Roomba is going to replace a janitor. It's a very small subset at the current time. So personally, my answer is I'm just excited to see linters get more powerful so that we can, from the bottom up, so to speak, really improve the code that's written, whether it's by humans or AIs.
Yeah, I agree. And one of the directions that we're trying to take Ruff in is we want Ruff to become just a lot more sophisticated and powerful over time, which are very vague terms, but in more specifics, what that would mean is we want Ruff to be able to do type inference and analysis and inference across files, which is just, those are really big upgrades compared to what we do today. So it's really nice. In Rust linter Clippy, that has access to, a lot of type information. And so it can implement a lot of really powerful rules and transforms that in Python, we can't really do because we just don't really know what any of the types of any of the variables are. We have rules that are supposed to only operate on dictionaries, for example. And we kind of have to guess in various places if something's a dictionary. And we can do a little bit of local type inference within a function, but we don't trace across function boundaries or anything like that. So that's the direction that we want to move in with Ruff over the course of the next year, which is just making it the highest confidence tool in Python, I think is one way that we've thrown it around internally. So just trying to increase the confidence of the diagnostics that we give out, that we produce, and make it so users can really rely on it when it tells you things.
How does type checking across files work with your extremely performance-friendly architecture now? Do you foresee any problems with, trying to cache information across files that then gets invalidated by fixing?
Yeah, definitely. Well, I mean, like we have a really simple architecture right now, which is we don't do any analysis across files, which is actually pretty amazing that we're able to get away with that. But we are, and it works. And so like we analyze every file independently and we can cache on a per file basis. That's like all going to need to change though, once we start thinking about, multi-file analysis. And it's pretty critical. I mean, it matters a lot too for like language servers. And language servers introduce their own set of challenges. Like for example, in like a language server, this is like an editor or an editor integration. The user could have like 2 files open and they could be like editing them, and maybe the changes haven't even saved to disk, but you might want to like reflect the changes in the user's editor. And so there's a mismatch between like the stuff that's on disk and the stuff that's in memory and like the user's representation of the code. So, these are all things that we need to be that we're going to be thinking about over the course of the next year. Basically, is like growing Ruff into something that can deal with analysis across multiple files, that can do really smart type inference in Python, that can support really good editor experiences. Like these are the kind of directions that I want to be taking the tool in, or that the team wants to be taking the tool in, and that I'm also excited about. Yeah.
Sure. Are there any other directions that you feel compelled to note as coming up soon or later for Ruff?
I mean, I think for Ruff, this is related to the editor integration thing, or to language servers sort of, but it's a very interesting technical problem. We want to make Ruff a lot more like error resilient. So, often like if you're in an editor and you're typing, like most of the time you have a syntax error, right? Like most of the time you're typing something that's not valid syntax because you type function and you haven't put the parentheses in yet or something like that. So we don't really support that at all right now. Like our parser, when it looks at invalid source code, it has to just kind of give up. And so if you're like typing and you have like a syntax error, all the diagnostics will like disappear until you like get back to not having a syntax error. And so we want to make our parser and the linter like error resilient, which means that when they hit a syntax error, they can actually still like try to parse the rest of the code. They can kind of guess at what's missing and keep going. And it sounds sort of crazy, but it actually does work, and like other tools do it, which is you try and build error recovery into the parser and say, okay, this looks like a function, but the parentheses are missing. So let's just keep going as if this is a function and parse the rest of the file. And so then you get a much smoother experience when people are in an editor, because while their files are in this broken state, you can still surface the same information and the same diagnostics. So like, again, it's related to me to like, we want to have a really, really good in-editor experience. And I think that's a big part of it, but it's not something we do today.
I actually have one area I'd like to get your take on you haven't brought up yet. I noticed on the Ruff site, you've got a lot of preview rules with names like missing white space around modulo operator, missing white space, multiple spaces, and so on. Are you building formatting concerns into your linter? And do you believe that formatter and linter are or are not intentionally the same tool in your space?
I think they're definitely different. So we do have a formatter, which is separate from the linter. So if you run Ruff check, that's our linter. If you run Ruff format, that's our formatter. And the formatter, it's totally separate from the linter. It's like, it's in Python, it's most similar to this tool called Black. In the web ecosystem, it's pretty similar to like Prettier. And like one of the problems we've run into is like the formatter came after the linter. And so we did have some stylistic rules in the linter that cause problems with the formatter. And we've had to document that. And we don't really want to remove those rules because some people use them and sometimes they're valid maybe if you're not using a formatter. But we have had to spend a lot of time like documenting basically the linter formatter compatibility, and achieving that has actually been quite challenging. And a lot of it comes from the fact that we did the linter first and then the formatter. And there are things in the linter that we built that weren't compatible with the formatter. The other interesting thing that's Python specific is in Python, there's something called PEP8. A PEP is a Python enhancement proposal. This is basically the process that they go through for language changes and other kinds of standards. And very early on, there was a proposal called PEP8, which is, it's a style guide. I think there's some debate around whether it's meant to be like how rigorously enforced it's meant to be as a recommendation or requirement for Python code. And there are parts of it that are sort of like ambiguous and maybe a little underspecified. But there's definitely a community of people who their main goal with formatting is to adhere to PEP8, which is less rigorous than running a formatter on your code. It is less well-defined than running a formatter on your code. But there's a bunch of lint rules that we have that are focused just on PEP8, in part because there are a lot of people who don't use formatters but want their code to adhere to PEP8. So like these are the kinds of dynamics that we have to be able to balance in our tools, which is we have just a really large, diverse community of users. And we want to be able to support like the group of people who don't want to use a formatter but want to use PEP8. We've decided that's something that we're going to support. We could decide it's something we don't want to support, right? But we've decided it is something we want to support, and that creates some of these challenges. But for me, like if I had my way, and I guess I could have my way, but like, if I was willing to just say whatever, we're going to do whatever we want, I'd probably take all the format related rules out of the linter. And I would say you should just use the formatter, and that would be that. But, these are the kinds of things that they're the kind of judgment calls and sort of balances that we need to make. And for now, at least we've continued to support that. But I suspect you agree with that opinion.
That's very, very mature of you to have an opinion and not enforce it. I'm of a similar opinion.
Thanks.
In the JavaScript space. We've shuffled all of our formatting rules into a separate plugin from core. But you're right. Yeah. A lot of users want them and do not want or even cannot use a formatter.
Yeah. And I think some of it, like, I guess one of the ways I develop empathy for that, right, is like to try and understand like why people would want that. Like, why would they want just PEP8 but not a formatter? And like in some cases, the feedback that we've received is like, these are people who are teaching Python, and like, it's a lot to introduce a formatter, but it's easier for them to introduce like, hey, here's PEP8, here's a document that talks about like how you should write code, and it's more limited, and like this is what we enforce. And so I don't know that I like completely agree with that, but I do definitely understand it, that like if you were someone who was teaching the language for the first time, or someone you were teaching it to people who were learning to program for the first time, having something like a document that spells out, these sort of like looser rules for general coding practice makes sense. And the other thing I will say, actually, this is like so specific, but since we got on this topic, there is one cool difference about cool is, I'm using the word cool very loosely here. There's one cool difference between like the linter and the formatter, which is a linter will tell you what's wrong and why, whereas a formatter will generally just change your code, right? So there's no formatter that I know of on Earth that will tell you why certain parts of the file were changed and like what they were violating. It just tends not to be in the design. Like when Prettier reformats your code, it doesn't tell you like this function was under indented, so it had to be indented more. Like that doesn't really happen. But a linter does, right? Like a linter actually gives you feedback on like, you had 3 blank lines here, but you're only supposed to have 2. And so I have more empathy for that as like a teaching tool, right? For helping you understand why your code is quote unquote wrong. But again, I think it would make everyone's lives a lot easier if we just use the formatter. It would certainly make our lives a lot easier. But yeah, anyway, it is an interesting topic.
Yeah, that's a good segue. Speaking of teaching, I want to end the interview on a few personal history questions for you. You haven't always been in your current role at Astral. You, I believe, were at Khan Academy. Is that right?
Yep. Yeah, I started my career at Khan Academy. I was an intern there the summer after my junior year of college, and then I went and joined full time and worked on a lot of different stuff. I mean, I started my career in web front end. Like we did a lot of Khan Academy was kind of like, I don't know if this is actually true, but it was said that it was like the first company to run React in production outside of Facebook. And the number one committer to React outside of Facebook was Sophie Alpert, who worked at Khan Academy at the time, then joined Meta. And so we just had like a lot of React. Like we were just really big on React. And so I wrote a lot of React in my career. And then I also worked on like our first like Android and iOS applications. And then our web, at the time, our web app was entirely written in Python. They since rewrote it in Go, which was like a years-long migration. Very interesting in its own right. But everywhere I've worked, actually, we've just had like a ton of Python. It's like sort of by coincidence.
That's how you managed to escape the JavaScript ecosystem.
A little bit.
A little bit.
I like the JavaScript ecosystem. I miss it.
It's a great place to be. So for a lot of people, for context, folks like you and I who've worked at companies like Khan Academy or Codecademy, there are full-on development teams. Not everyone there is teaching, but you are on the content tools team at Khan Academy, which helps make tools that help other people teach code. And of course, you were likely, mentoring, teaching other folks internally. Are there any particular lessons or ideologies that you still keep with you from Khan Academy, the good pedagogy there that you've taken to using linting today?
I mean, actually, mostly it's like, I think it had a massive influence on me, but mostly from the perspective of like engineering and building engineering teams and like shipping code and technical best practices and all that. Like the value of code review, I think was like really, I keep using words that sound pejorative but aren't. It was really hammered into me. I just learned so much from really good code reviews at Khan Academy. And I've tried to carry that with me for the rest of my career. Like I kind of view code review as like maybe the most important avenue for learning and teaching other developers. That's maybe not everyone would agree with that, but like I don't know, at least in my career, I got so much out of that. I think having clear values on a team is another thing that I got out. Like we had very clear like engineering team principles. And that's something I've kind of tried to carry with me too through other engineering teams in my career. So I think of my time at Khan Academy as like where I learned how to be a developer, basically, and hopefully how to be like a good developer. And I don't know, I just learned so much. It was like such a good experience for me.
My last content question for you is, you do trivia in your spare time. What are the benefits of Learned League or Learned League?
Learned League. So I'm in a daily online trivia league called Learned League, and I love it. I'm not that good. So if you're in Learned League, don't look me up because it's like it'll be mildly embarrassing, but like I do love it. And the core concept behind it is like you're in a division with like there's like 20 of you, and every day you're playing against someone, and everyone in the league has the same 6 questions that they need to answer. And you have all day to answer them. And it's purely honor code that you don't look them up or you don't cheat in any way. So you have all day to answer these 6 questions. And you're both trying to answer the questions and you're matched up against an opponent. Like it's Charlie versus Josh. You also have to rank the questions in terms of how difficult you think it will be for your opponent to get them. So there's an offensive component, which is like answering the questions. And there's a defensive component, which is, I think there's no way that Josh knows this one, but he definitely knows this one. And then at the end of the day, it's sort of, there's a scoring system based on how many you got right and how your opponent ranked them for you. And you either win, lose, or draw. And the season just proceeds like that. So I don't know. I've always been really into trivia, despite being not like that great at it. Like I watch a lot of quiz shows in my spare time, and I spend less time now on Learning League. Like I used to spend a lot of time on Learning League. Like you have all day to answer all 6 questions. So you'd be surprised, like, you might think, oh, you see a question, you either know the answer or you don't. You'd be surprised how much time you can spend thinking about a question that you might know the answer to. So that's one thing I like to do. I like to do in the spare time that I do have is like ruminate on those 6 questions all day.
That's fantastic. Do you feel like it helps you with programming to try to get your mind in the mindset of trying to think on a rattle like that?
I think it can. Yeah. I think it's helped with my memory, maybe. And it has actually made me like more educated on various topics. Like I did a deep dive for a while where I was trying to get a lot better at art history. I know this is so nerdy, but I was trying to get better at art history. So I started doing spaced repetition, where I was looking at paintings and I would have to name like the painting and the artist. I just did this like for 10 minutes every day for like, 6 months or something. And it actually like very materially changed like how much I know about like artists and art history. And some of it's superficial, like being able to name who painted a painting is not actually like important, right? But it then pushes you to understand things like, oh, what is like Fauvism? Like what is abstract expressionism? Like you kind of learn, it's a vehicle for learning more about topics that you didn't already know about. So I don't know. It's something I like to do, and it's something I share with, there's like a group of my friends who are also in the league, and we always like debrief on the questions afterwards and talk about what we knew and what we didn't, and lament the things that we almost got right and all that kind of stuff. So it's a good like form of social connection too.
Socialization and connections and friends are great, but also specifically art history actually has a lot of really interesting applications in modern development. I saw a fantastic talk in the last year at Weiwei Web, Isabella de Coupes, pardon the pronunciation, talking about how form follows emotion, not just function, or a lot of modern designs like, say, the iPod, the iPhone, were reactions not just to the needs of the consumer, but how people had previously been trained in design, in art, to work with things like skeuomorphic design in the iOS interfaces is a common example. That's relevant and useful, not just fun and interesting.
Yeah, exactly.
Great. Well, Charlie, this was absolutely phenomenal. Thank you so much for coming on. I love talking to people who are working at the latest, greatest, cutting edge open source stuff that pushes the industry forward. So Really excited that we got a chance to talk. Is there any way that you would prefer people find out more about you or reach you on the internet?
Best thing is to follow me on X. I post a lot of stuff there. And then obviously my GitHub too is, if you want to be at that level of detail, there's a lot of stuff coming through my GitHub as well. But X is the best way to keep on top of, things that are happening for me personally and for Astral and for Ruff and UV.
Great. And both of those are Charlie R. Marsh.
Yep.
Super. Well, for Software Engineering Daily, this has been Josh Goldberg with Charlie Marsh and Astral and Ruff. Cheers.